was f of x equals x squared. And our discussion before about f of x equals x squared was that a was 1, b was 2, and c was 3. Excuse me. 0 and 0. Getting ahead of myself. Cool so far? That's going to come into play when we look at this later, because that has something to do with what's going on down here. Fair enough? Okay, that has something to do with that. All right. Let's say that again. Maybe. Okay, maybe not. I hear voices. I want you to be heard because you guys say good things. That's okay. Come back. All right. Now, let's set up f of x plus 1 minus f of x. All right. So we're going to go f of x plus 1 minus f of x. Now, we don't like the generalization, so we want that to be f of 5 minus f of 4. Right? We're calling this 5 and this 4 because we want to use these numbers right here. That was the vote, I think.
Yes.
Even though I only got about 2 votes in 30, but we're going to. That's kind of how America works anyway. So those who vote get something. So here's a tricky question, though. What's x? Is x 5 or is x 4? X is 4. X plus 1 is 5. Exactly. Very nice, my friend. Very nice. So just keep that in the back of your mind. We know that x, if we're doing it this way, we know that that means x equals 4. We're going to need that as well. We're going to need that as well when we do the calculation in a minute. Cool so far? Ish. Okay, we're getting there. All right. Now, when we did f of 5 minus f of 4, what is f of 5 according to this chart?
Say it again.
What is f of 5 according to this chart? Said a different way, what is the y value when x equals 5? It's 25, isn't it? 25. What is the y value when x equals 4? 16. What is 25 minus 16? None. We figured that out. That's what we just calculated in the chart. This will give you the exact same 9 without the chart. Watch. Ready? 2ax plus a plus b. Let's bring that over there. Let's bring that over there. Okay? No, plus a plus b. 2, what's a?
1.
What's x?
4.
What's a? What's b?
0.
What's that equal to? 9. What this saves you from having to do is create the chart in the first place. If you make peace with the algebra, which doesn't look like we're exactly ready to do yet, that's okay. I'm learning something by this discussion. I'm learning something from this discussion very, very clearly, actually, that you're not a huge fan of the algebra. It's actually less work to do it the way we did on the middle board, although it doesn't seem it.
No, it does not at all. Are you kidding?
Well, suppose x was something like 32. You're tracking the motion of your building. I was just back in Philadelphia recently, and they have this huge freaking thing set up in the middle of the airport. It's one of those Rube Goldberg-looking contraptions with rails on it, with the metal balls rolling around on it. Ends up in, like, you've seen the OK Go video for This Too Shall Pass with the 4 guys and the paint and the cards. It's this crazy Rube Goldberg machine with big metal balls that go down tracks, and they bounce off of things, and they end up in buckets, and the weights turn, and they keep cycling and cycling. To build one of those things, you have to have some understanding of physics. Physics, dropping things on Earth, things going down ramps on Earth, has everything to do with quadratic functions like this. So, if you want to make sure that thing will keep running and not fart out, you have to make sure that it's set up for 32 days, 32 months, 32 years perhaps in advance. You don't want to make a chart that's going to chart the position of these balls over the course of 32 days. You want to develop a function that describes how the ball moves and then use that to predict where it's going to be versus the chart itself. I know it seems like a lot more work to do it this way. It's not. On average, it's not a lot more work. It's actually less work to do it generally than it is to do it. But I think I've lost about 99.9% of the class. Maybe I should rethink this question. How many of you say to hell with the algebra and do it with the chart? So to hell with the algebra, do it with the chart. The chart makes sense. The chart makes sense. Yeah, the algebra, we hate the algebra. We hate the algebra.
I like algebra.
Algebra is good. Algebra's fantastic, but I'm a little nervous that what I'm worried about. Here's what I'm worried about. I'm worried I've lost the point. Because at this point, go ahead, my friend.
Say with the chart, you give such defined values.
Yes.
But when you're doing algebra, you don't have those defined values, so it makes more sense to do
Unless you
algebra than
ask
to have
about
a chart.
It totally does. It totally does. The problem, though, is, does anybody remember why we started this problem in the first place?
That's what I'm trying to remember.
That was my fear. My fear was we got so lost in the algebra, we forgot what the point of the original problem was, which was what?
Why the second difference?
To find out why the second differences were constant. And we're only about halfway there. So I'll tell you what. Because I don't want to waste the time we just had, I have an alternate plan. Let's take 5. While you guys take 5, let me do E6, if that's okay. I'll do E6 real quickly on the board, put it next to E5. Then I'll show you the subtraction of those two and show you what I'm talking about. I'll do E7 too while we're at it. We'll get them all on the board. I won't require you to do this kind of algebra on an exam. If you're worried about that, don't worry about that.
I am worried about
Don't
that.
worry about that. I'm telling you not to worry about it. Are you listening to me?
I am.
Don't worry. Okay. So take 5. Let me get some more algebra on the board. I think that was the problem. As soon as we started doing this, that's when I could just see the lifeblood escaping. I go, oh, there they go. Now, but I had them. Now they're gone. So let me do E6 and E7, and then we'll come back together, regroup, and I'll show you what the hell I'm talking about. Is that okay? Maybe ish. Let's take 5. Stretch out. Let me do some algebra.